Okay, so this is 2025 Feb March paper 52. Starting from question number 5, brass is an alloy of copper and zinc. An experiment is completed to find the percentage by mass of copper in a sample of brass. In the experiment, the sample of brass is reacted with an excess of concentrated nitric acid. This forms a solution containing copper 2 plus ions. The amount of copper 2 plus ions formed is determined by titration. A student uses the following method. Number one, weigh a glass beaker and record the mass. Okay. Add approximately 1 gram of powdered brass to the beaker and record the mass of the beaker and the brass. Transfer the brass into conical flask A, which contains excess concentrated nitric acid, and then reweigh the glass beaker and record the mass. Add aqueous sodium carbonate dropwise to flask A until a precipitate of copper carbonate appears. Then add dilute ethanoic acid dropwise until the precipitate is fully dissolved. Transfer all the contents of flask A to 100 centimeter cube volumetric flask and make up to the mark with distilled water. This is your solution B. Transfer 10 from this 100 into of solution B into a conical flask C. Add 10 cm cube an excess of Ki to flask C. Okay. Titrate the contents of the flask C against sodium thiosulfate. Concentration is given using a starch solution as an indicator. Repeat Repeat steps 7 to 9 until concordant results are obtained. We do titration multiple times until we get the concordant results where the difference is 0.2. Okay. So in question A, they are asking, suggest why step 3 in the experiment should be completed in a fuming cupboard. Step 3 means this is the step where you are using concentrated nitric acid. Since we know this is concentrated acid, so it releases fumes of NO2. So NO2 is a toxic gas. So that's why we are supposed to use fuming cupboard so that, in a fuming cupboard, there is a very uh, strong exhaust system. So it sucks the fumes of nitrogen dioxide gas so to protect us. So NO2 is a toxic gas. That's why we are using fuming cover, and that's it. It's a 1 mark. Explain why the glass beaker is reweighed in step number 4. If you remember, he was saying reweigh the glass beaker and record the mass. Reweigh the glass beaker and record the mass. Why he is doing this? Because to find the accurate mass of brass that is transferred by taking difference. Sometime might be possible that when you are transferred content of brass into another beaker, so might be possible there are some particles which are sticked to the surface of the glass. To avoid this, like how much, you know, we are supposed to reweigh the glass beaker so that I can take a difference to have accurate mass, because I would be using the same value in next calculation. Okay, it would give you accurate results. So so what I have written, to be able to find the accurate mass of brass that is transferred by taking difference. So I will be finding out the mass of brass that is being transferred. I will be I will be neglecting the mass of those particles which are sticked to that glass surface. So I would be using those particles in my calculation which are being transferred. That's why I'm reweighing the glass beaker to find the accurate mass. Okay. Then in C, name a suitable piece of apparatus to transfer the 10.0. It shows that this is more accurate. I'm supposed to use volumetric pipette. 10 cm cube of volumetric pipette. This is accurate. Okay, because they have written 10.0. If they will be writing 10 cm cube, so you can use Bayesian cylinder as well. 10 is not an accurate number. So you have to see carefully what is written. Okay. And then in step 9, they are saying in step 9, Titrate the contents of the flask C against sodium thiosulfate. Okay. So in step 9, this much sodium thiosulfate is used. This is solution. This solution is prepared from zero point 0.2 mole per dm cube sodium thiosulfate. Okay, this is more concentrated, right? So this is your stock solution. This is your stock solution. So if I have a stock solution, how can I prepare this much concentrated solution? So describe how to make 100 centimeter cube of this one from the stock solution whose concentration is given, that is 0.2. Give the name and capacity of any apparatus you would use. Write your answer in a series of numbered steps. Number one thing is that if I have this stock solution, so how much volume should I take from this solution to make this solution? So I have to find out the volume first. I would use dilution factor C1V1 is equal to C2V2. This concentration that is given, okay, I have to make how much solution? 100 centimeter cube solution, right? I have to make 100 centimeter cube solution from this much concentration. So how much volume should I take from zero point 0.2 mole per decimeter cube concentration to make 100 centimeter cube of 0.06 mole per decimeter cube solution? So I would be solving it. I would be getting 30 centimeter cube. I have to take 30 centimeter cube of sodium thiosulfate. So I have written measure 30 centimeter cube of sodium thiosulfate from burette and transfer it to a volumetric flask whose volume should be 100 centimeter cube, and add distilled water up to the mark. Shake well so that the content is mixed in a proper manner. Yes, your solution is prepared. This is 100 centimeter cube solution whose concentration is 0.0600 mole per decimeter cube. So always we make a solution in this manner. First of all, I have to find out the volume. Stock solution is given. So then I have to think how much volume I have to take from the stock solution to make this much to make this much concentration. Okay. Then the measurements collected using during steps 1 to 4 are shown in table 1.1. Mass of glass beaker, they have measured, it was 25.55. Mass of glass beaker containing powdered brass, it was 26.65. Then mass of glass beaker after transferring brass, so that is 25.65 grams. Determine the mass of powdered brass added to conical flask A. So I have to find out the mass of powdered brass. So how can I find it? So I can say mass of powdered brass is equal to mass of beaker plus brass minus mass of beaker. Mass of beaker. It's going to be 26.65 minus 25.65. So I would be getting exactly 1.00 grams. This is the mass of powdered flask. I have subtracted this one from this one. Higher minus lower to get the positive answer. Mass should always be positive. Then they are saying final burette reading, initial burette reading. So I have to find out the difference. I have subtracted, I have subtracted it, I have subtracted it, I have taken a difference. I got this one, this one, this one, and this one. 24.05 minus 3.25. I would be getting this one. 24.80 minus 4.50. I would be getting this one. Same goes with this and same goes with this. Then, then, I have to take a mean titer. Before going to take a mean titer, I have to find out the concordant results. So these are the concordant results where the difference is minimum, isn't it? This is 20.3. This is 20.3. And this is 20.4. This is 20.4. So that's the answer. So I have to take a mean titer using these two values. I would be getting this one, 20.35. How can we take a mean titer? Sum of all the values divided by the total. So I have two values divided by the total. I got the mean titer. Then they are asking to find out the percentage error in the titer, means in the burette. You know, whenever we use burette, we take reading twice, initial reading and final reading. Of course, the error would be multiplied by 2. Whenever those apparatus which we use twice, so we have to multiply the error by 2. So the percentage error, like the this is for the burette. I'm going to multiply this by 2 divided by the mean titer, like uh, divided by titration 3, whose titer is this one. So I would be getting the percentage error. Simple. Examiner has specified the number of titration. Otherwise, this value is variable. Okay, this is fixed. This is fixed for the burette. This value is variable. You can put any value as per question. Okay. Then in step 8, copper ions react with iodide ions. Okay. The ionic equation is shown. In step 9, thiosulfate reacts with iodine. Equation is shown. Okay. Using a second sample of gas, another student determined the mean titer to be this one. Calculate moles in the student's mean titer, whose volume is this. You know, mole per decimeter cube. You know, mole per decimeter cube. 1 decimeter cube. 1 decimeter cube is equal to 1000 centimeter cube. So it means that 1000 centimeter cube contains this much moles. How many moles would be there if I have 17.35 centimeter cube? I have cross multiplied it. I got the answer. Then they're saying use the equation for the reaction 4. Okay. And your answer to H1 to determine the amount of iodine. Since I know the mole ratio between thiosulfate and iodine, that is 2:1. I know the moles of sodium thiosulfate. I have to find out the moles of iodine. Cross multiplied it. I got the answer. This is the moles of iodine. And then use the equation for reaction 3. Use the equation for reaction 3. And your answer to H2 determine the amount in moles of copper plus 2 in 10 cm cube of their solution B. Um, this is the mole of iodine. The mole ratio between copper and iodine is 2:1, as you can see in this equation. This one, no, this one and this one. Okay, 2:1. I did the same thing, 2:1. I know the moles of iodine, that is this. I have to find out the moles of copper, cross multiplied it. I got the answer. This is the mole of copper plus 2. This mole is present in 10 centimeter cube. How many moles would be there if I have 100 centimeter cube of volume? Okay, because you know why I'm finding in a 100 centimeter cube volume? Because if you can see in previous steps, the volume of the standard solution was 100 centimeter cube. So that's why I'm finding the moles in 100, like I'm finding the moles in a total volume. And then afterwards, I have to find out the mass of copper. Mass is equal to Mr. Moles. The atomic mass of copper is 63.5. I know the moles. I have multiplied it. I got the mass of copper plus 2. And then like I got the mass of copper, and then they are asking percentage by mass of copper in the second sample of powdered brass. If you remember, when we used to find the mass percentage by mass of anything in a compound, so what we used to do, let's say I'm asking, can you tell me the percentage of carbon in sodium carbonate? So you know what we used to do? Mass of carbon divided by the total mass of carbonate multiplied by 100. Isn't it? Isn't it? Individual mass is in the numerator. The total mass in the denominator multiplied by 100. Same goes with this. Individual mass should be in the numerator divided by the total mass. They must be given in the question. Let me check. Let me check. Let me check. Yes, they have given the mass of brass. They have given the mass of brass, uh, 1 gram of powdered brass. Okay. And if you remember, we have also, yeah, okay. And you can see what I did. You can see what I did. The total mass of uh, powdered brass, that is 1.05 grams. They have given in this. The mass of the second sample of powdered brass was 1.05 grams. So individual divided by total multiplied by 100. I got the percentage by mass of copper. Simple. Simple is that. Whenever you are going to find out the percentage by mass of anything, so you need the individual mass divided by the total mass and then multiplied by 100. That's it. Okay.